Hi team, this is a video on Surds. It's really an introduction to Surds. Now these are something new that you've not seen before, so obviously I'm going to need your full attention here. It might be worth taking a few notes throughout the video as well. I'm going to start by explaining what a Surd is, and then we're going to go through some examples. At each point I'll have a chance for you to try one. Now it might be that you get to a certain point and then want to go and try the sheet and then come back to the video, or it might be you want to watch the whole video and then revisit it. But there's quite a lot of information in the video, so make sure you do revisit it if you do get stuck. Okay, I'm not expecting to remember everything I go through now, but it's a resource you can return to. So, a surd is any expression which in its simplest form includes a square root. Okay, I'm going to show you a few examples and a few non-examples to make this clearer. So these are a few examples. Got the square root of 43, 4 times by the square root of 3, and root 3 over 5. Today we'll look at ones that look a little like the first two, but we will deal with ones that look a little bit like the third one in a future lesson. So we won't be dealing with fractions today. A few non-examples are these two. Okay. Now, obviously this bottom one it's just a fraction, 3/9. It is a number that never ends, much like most surds. Okay, so that's why it's there. This one looks a lot like the surds, but the reason why this isn't an example is that the square root of 16 is just 4. Okay, it's not a surd, it's just an integer value. Okay, so the difference there is important, that these numbers don't square root into an even number. The square root of 43 is not a whole number. The square root of 3 is not a whole number. So let's look at what we're going to have to be doing with them. Okay, we're going to have to be simplifying surds primarily. Okay, we'll look at calculating with surds a little bit today, but primarily we're going to be simplifying with surds. So we might get this value, we'll be given this, and it's asking us to simplify the surd. Now, it might not be immediately clear what you do, but I'm going to show you, and then it will become clear why I've done what I've done. Okay, so I've got the square root of 200. Now I can rewrite this, and you'll see why I rewrite it like this in a second, but I can rewrite this as the square root of 100 multiplied by 2. Okay? I've not changed the value. All I've done is rewrite 200 as 100 times by 2. We know that's the same thing. I can then rewrite this as the square root of 100 multiplied by the square root of 2. I've broken it into two different square roots. Okay. The only reason I can do this, and this is a really important point, the only reason I can do this is because this is multiply. Okay. If that said, the square root of 100 plus 2, then that would not be the same as the square root of 100 plus the square root of 2. Okay, that's really important. The only reason I can do this splitting is because I've got multiply there. So if I've got add, I cannot do it. Now, once I've got that, once I've split this, it should be clear now that I can start simplifying. The square root of 100 just has a value. It has the value of 10. And then multiplying that by the square root of 2. Now, the square root of 2 is not a whole number, so I'm going to leave it as a square root. I'm going to write that more simply just as 10 times by root 2. And that looks like the surds from the previous examples. That is the process of simplifying a surd. I'm going to put one on the screen for you to have a go at now. Pause the video, have a go. So our first step, we should have gone, right, let's write this as 9 times by 2. That gives us the square root of 9 times by the square root of 2, which gives us 3 root 2, and that should be our answer. Now, let's look at another example together. Let's say we've been given this example. Now, on the previous ones, it was fairly easy to see what my square number was. But with this one, my instinct might be like, right, okay, let's rewrite this as 2 times by 24. But I'm in trouble now. Neither of the numbers in my square root are square rootable. The square root of 2 is not a whole number. The square root of 24 is not a whole number. So I haven't helped myself simplify. I haven't helped myself simplify this. I'm always trying to make things easy for myself. I'm always trying to make sure I simplify things. So what I'm going to look for is a square number that goes into 48. Okay, a square number that goes into 48. So I might go, right, well, 4 goes into 48. It's perfectly true. And then I can go, right, 4 times 12 is 48. Okay. My challenge, though, is that I've missed something here. And what I've missed is there's another square number that's bigger that goes into 48. So I need to make sure that I'm always going to use the biggest square number. So if I need to, I can write out my factors of 48. So I've got 1 times 48, 2 times 24, 3 times by 16, 4 times by 12, 6 times by 8. Now those are all of my factors of 48. I want to find the biggest square number. I've already seen and already noticed that 4 is a square number, but I actually have this number, which is the biggest square number. So what I want to use is always the largest square number, so I'm going to write in 3 times by 16, which I can rewrite as 3 times by the square root of 16, which I can simplify to 4, which is the square root of 16, root 3. And like with algebra, I'm always going to write my whole number first. I'm going to put another one on the screen for you, and this one's going to challenge you to identify the largest square number. So we're always looking for square numbers. Have a go at this question for me, please. Now, the trick here, the thing that's more difficult, is some of us might have gone, right, 32 is 4 times by 8. Easy. But again, I've missed another square number there, and what I should have done is use 2 times by 16. That gives me the square root of 2. Oh, let me make that a little smaller. Multiplied by the square root of 16, which is the square root of 2 times by 4, which is 4 root 2. That is my final answer, the simplest answer. Now, let's have a look at another example. This time I've been given one which has an integer in the front, and it isn't in the simplest form. This question is slightly more difficult, but there's just one extra step. What I need to notice is that 5 root 32 is 5 times by the square root of 32. Now I've just worked out that the square root of 32 is the same as 4 root 2. So what I've done is said that that is the same as 5 times by the square root of 16 times by 2. That is the same as 5 times by the square root of 16 times by the square root of 2. And you'll notice how I'm being really careful to make sure my square roots are really clear. Which is 5 times by 4 times by the square root of 2. And I can clearly multiply these together, and I get 20 times by the square root of 2, and that is my final answer. Again, I'm going to put a question on the board on the screen for you to have a go at. Pause the video and have a go now for me. What we should have done is gone, okay, 3 times by the square root of 50. That's the same as 3 times, and this one's a little bit more difficult, we've not seen this one, but we should have 25 times by 2. 3 times by the square root of 25 times by the square root of 2. 3 times by 5 times by root 2, which gives us 15 times by root 2, which I can just write as 15 root 2. And that's that answer in a more simple form. Okay, that's the simplest form possible. Now that's it for simplifying surds. Okay, for simplifying surds. What we're going to look at now is making a calculation and then simplifying it. These are very simple calculations. We'll go through 2 examples. Okay. So we're going to calculate the following. I'm going to give our answer in the simplest form. And that's a key bit from our question. Is asking us to give our answer in the simplest form. So I've got root 5 times by root 32. Now it's almost like going in reverse. What I'm going to do this time, instead of trying to simplify them individually, I want to make it back into one bracket, or one square root. I know that that's going to be the same as the square root of 5 times by 32. And now I want to see what 32 times by 5 is. 5 times by 2 is 10. 5 times by 3 is 15. Add 1 is 16. So I can rewrite this as the square root of 160. At this point, I want to see what my highest square number in 160 is. Okay, and you can try just your square numbers on a calculator dividing by 160, dividing each of them 160 by each of them if you want to. But hopefully we should be able to see here that this is going to be the same as 16 times by 10, which is the same as root 16 times by root 10, which is then the same as 4 root 10, and that's my final answer. One for you to have a go on the screen now. So pause the video. This question, we should see that we're going to have the square root of 3 times by 50. That gives us the square root of 150, which is then broken down into the square root of 6 times by 25, which is the square root of 6 times by the square root of 25, which is then root 6 times by 5, and we'll write that as 5 multiplied by root 6. Okay. In each case, I've reformed them into one square root and then found the simplest form. Let's look at one more example for me of the kind of the most difficult question we'll look at today, and that's this question here. The only thing that's more difficult about this is we now have coefficients of each of the brackets, but my process is very similar. There's just one extra step. What I'm going to do is rewrite this with all of my multiplications in it. It's going to be 2 times by root 5 times by 3 times by root 4. Now I know that I can multiply numbers in any order. So what I'm going to do is do 2 times by 3 and get 6. Okay. To make that really clear, I'll write it out in a different order. Okay. Now 2 times by root 3 gives me 6, and then root 5 times by root 4 gives me the square root of 5 times by 4, got 6, multiplied by root 20. Now at this point it's similar to the previous question we just did, and I need to find the highest square number in 20. Okay, so I'm going to say 6 times by 5 times by 4, 6 times by root 5 times by root 4 gives me 6 times the square root of 5 times by 2, and again I can multiply my whole numbers to give me 12 root 5. Okay, 12 root 5. One more question for you to have a go at. And what you should have done is as follows: times by root 15 is 20 root 15. Easy as that. Okay. Any questions, let me know, but get started on the sheets when you can, please. Thank you.